So good afternoon, everyone, and welcome to the next session within the work stream on leadership in a post-COVID-19 world. So I'm delighted to welcome Andy Grayland, who's going to speak at this session specifically about cybersecurity and resilience. So Andy's been working with Martin, the local government digital office, for the last 2 or 3 years or so. Prior to which Andy spent a big chunk of his career in the MOD, working on collaboration and system security. So Andy, thank you so much. Just another couple of pieces of housekeeping, please. So there will be time at the end for a Q&A session, and it's our expectation will be around 10 minutes to do that. Usual format, if you've already attended some previous sessions, which is your camera and your audio should have been muted by the team. If for some reason yours is not, I would ask that you do so just to protect the bandwidth so that we can get some continuity. If you have any questions during the course of the session, please put them into the chat box, or alternatively, when we come to the Q&A session towards the end, you can raise your hand and the team will unmute you. As always, the sessions are being recorded and they will be available on the Academy site afterwards, and will be there going forward. So thank you once again. Andy, over to you. I know you're going to share your slides, but I'll hand over to you now. Thank you.
Thank you for that introduction, Hugh. Can I just check everyone can see the slides?
Yes.
Great. So 500 million. That's the number of tasks that the PC sitting in front of you right now could have been asked to carry out by other machines across the internet in the time Hugh took to deliver his introduction there. This number is unfathomable for most people, so let me put that into perspective. If you were a very diligent and fast worker who could complete one task per second, it would take you 70 years of working 40 hours per week to accomplish the same work. Computers are designed to talk to each other and assign each other tasks very quickly. It's one of the reasons they're so good at what they do. In an ideal world, we could assume that all of the tasks other computers ask ours to do are based on good intentions. But unfortunately, we don't live in an ideal world. A huge number of tasks that are sent to your computer from the internet are trying to do you harm. The subject of computer security may seem like it's as much of an unfathomable topic as understanding the scale of 500 million, but in reality, the sole purpose of this specialization is to ensure that the good tasks get through and the bad tasks don't. There's no more complexity to it than that. Knowing this one simple fact is all you need to know about cybersecurity as a senior manager of a business function or organization. Every single piece of security hardware, software, or training that your budget pays for goes towards the single purpose of ensuring that the good tasks get through and the bad ones don't. So now we're all experts in cybersecurity, let me introduce you to the subject of today's presentation. The last year has really shaken up what we consider to be plausible use cases for IT in delivering public services. We've had a massive focus on remote working, and in many cases, we've had to reimagine our business processes across the board. Just as how we use IT has changed, how we need to secure that IT has had to change with it. In this presentation, I'm going to talk about securing modern business processes in the new normal and beyond. And I'll introduce an innovative and dynamic security model for the future of people-focused working practices. So in terms of what we're going to cover today, what do we actually want from digital transformation as organizations? Why is it so hard to achieve? How do we achieve the future we want in a safe, secure, and affordable way? And where do we start? So what do we want from digital transformation? Now, I've got a list here. It's not going to be an exhaustive list. I suspect you could add as individuals even more to it. But I think this will give us a good idea of that we're all on the same page when it comes to digital transformation. So the first most important thing is a seamless integration into modern business processes. We don't want IT to be the main event of our public service delivery, but we need that IT to support the service delivery that we want to achieve. And we do that by having business function-led service design. So rather than the IT department within your organization saying, here's what's available and you working around that, it makes much more sense for the business to say, here's what we want to achieve as a business function and how do we achieve that? And what the ideal result of IT in the end is that the functionality of that IT is invisible to the business function and doesn't get in the way of it. What we want is to be able to achieve exactly what we can do at home in the same way that Google works and Amazon works when we want to use them in our homes. We would like a similar user experience when we're at work. We want to work on any business process from any device, anywhere, at any time, safely and securely. And for anyone who's seen the news over the last 6 months where companies are continually being attacked with ransomware, we want to be able to protect against that scale of cybercrime when we transform our businesses. Now, the reason most of you will be here, and in fact, probably the reason Scotland Excel exists in the first place, other than the paperwork associated with procurement, is because there's no point talking about all this stuff if it's not affordable. So why is this so hard to achieve? In order to answer that question, we need to go back to the advent of the electronic office in the mid-80s, where we decided that we could help our business processes by having computers perform some of those tasks for us. And we had this model where there was a head office and there was some servers and some data, and everyone worked within the head office. There might have been a connection to the internet, but in the mid-80s, it's unlikely that you would have had something along those lines. As we progressed through into the early 90s, that would become more and more common. But we immediately ran into a problem, and that problem was the one of the fact that not everyone in this ecosystem has our best intentions. It has best intentions for us. So how did we fix this problem? Well, we came up with the idea of having a secure perimeter. And what we did there was put a big barrier around our head office and said, everything on the inside of here is trusted. Everything on the outside is not trusted. And we put a big firewall in place that said, is this good? Is this a good task or is this a bad task? And it filtered out those tasks, and only the good tasks got into the secure perimeter. Now, as we move forward to the late 90s and early 2000s, a single head office wasn't enough. We wanted to have that working ability in all of our spaces that we ran as organizations. So we maybe introduced some regional offices, and we applied the same security paradigm of the secure perimeter to those regional offices. We mimicked the infrastructure, and we effectively created one large network in multiple places that people could log into and use the same systems and services. So we're still not talking about remote working here, but we're literally talking about other buildings that we own and have complete control over that we're putting a secure perimeter around. And then as we moved into the mid-2000s and approaching 2021, we decided that it might be a good idea to have remote users. Now, these are users who exist neither in the head office or in some kind of regional office where we've got that secure perimeter. And we've tried to apply the same security paradigm to those remote users. We've said, how do we increase the size of our perimeter to encompass what these users now need to do who are neither located in the regional office or in the head office? And ultimately, when we try to define what the size of that secure perimeter is going to be, the only answer we can come up with is, well, really the entire globe. It's the world. Because we're going through the internet, the size of our secure perimeter is the entirety of the planet. And what we're finding is that as we move into more and more remote users and more remote needs, the costs associated with securing that one perimeter are extortionate. Most people can't afford them, and what we end up doing is making a trade-off between usability, what these remote users are allowed to do, and cost. And if we can't afford the cost, we have to get rid of some of the functionality for users. Now, to complicate matters further, these are just the technologies that the IT department know about that operate within your company. There's a whole other realm of IT devices and services that we call shadow IT. And what this is IT devices or services that are running within your network that even your IT department don't know about. Now, you might think, well, of course, my IT department has a really good understanding of all of the devices and services that run into it, but there's a good chance you would be wrong. Recent surveys in America suggest that your average IT department within a large-scale organization might have a handle on about 80% of the devices and services running within their real estate. Good companies might get up to around 95% coverage of knowing exactly what they've got in terms of devices and services. And the absolute very best companies, the ones your Amazons and defense departments, might get somewhere around 99%. And what this means is that there's a risk there to our secure perimeter, no matter what we manage to protect, just based on the shadow IT that can either exist within our secure perimeter or externally and operate with our devices and services around the network. So how would someone with nefarious intentions actually get inside our secure perimeter? Well, the most common way is stolen user credentials. And some of you may have seen a news story featured in FutureScot last week about 40,000 Scottish public sector user credentials that were hosted on the dark web, available for download. We might also see, and it's not so popular now because I think we've covered most of the security angles for this, but lost devices. Anyone who was in IT in the early 2010s would have seen the news stories all over the papers about people leaving laptops on buses, mobile phones on buses. It could be a lack of security patches, and that is that we have this boundary. It's just running equipment and services, and if those services are not kept up to date, a hacker might be able to abuse a problem with that service in order to get into your network. It might be to do with incorrect or out-of-date configuration, and that is that you have added a new aspect to your network and haven't updated everything else on the network to understand how that works, and that might leave a little bit of a gap in your armor. And the key thing to realize here is that the attacker only needs to succeed once, and you need to be right every single time. That is almost impossible. In fact, I would say it is impossible to achieve that. And in computer security, what we're trying to do is not stop an attacker, but is to increase the amount of time between successful attacks and minimize the impact of such an attack. There is no organization on the planet that I would say will never be attacked given a long enough period of time. So what happens when an attacker is inside your secure perimeter? Well, they're free to move through the entire network. Whether they get in through the regional office or through a remote user, they're effectively inside your head office at that point, and they're trusted like a normal user. The way that we set up these secure perimeters is that we say, here's a list of things that you can't do. And that trusted user can do everything else. Now, normally that trusted user is one of your members of staff, and they only do a set number of things. But when an attacker comes in, they will try to do all of the things that they might want to do to break your network. And unless it's specifically listed as that they're not allowed to do that, they will be able to do it just fine. And this is exactly how ransomware affects large organizations. You will have seen the huge spike over the last 6 months in academic institutions, in the health service in Ireland, the large US oil pipeline. All of these companies went through the same process, and that was a single user credential was stolen. The attackers gained a toehold into that secure perimeter. Over months, the attackers worked to define that internal network, to then take down every single machine at the same point and cause tens of millions of pounds of damage and fines. So what is the solution to this? We've got this secure perimeter that's not really that secure. It's costing us more and more money to maintain this secure perimeter because we're effectively using a paradigm that was invented in the mid-80s for a completely different environment that we now work in. So instead of having this one single secure perimeter and trying to expand it to the size of the globe, what we can do is have a number of micro perimeters. And by focusing our energies and our resources on securing these individual devices, what we do is we stop pretending that we have a single entity that is a network that we can trust people, and we move from a situation where we say, you can't do that, to you can do this. And why is that better? Well, with the situation where you say you can't do that, you have to be really, really confident that your list of things you can't do is 100% of things that an attacker might want to do to defeat your network. When you move to a model that says you can do this, it's very difficult for you to have made a mistake that will enable an attacker to do anything on the network. This type of model, where we reduce the security perimeters down to lots of micro perimeters, and we move from a you can't do that to a you can do this model, is called the zero trust security model. Its mantra is never trust, always verify. Now, some of you may be sitting there thinking this sounds like a bit of a headache for users. Looking at it in terms of how a human would interact with this situation, can you imagine if every other employee in your workplace never trusted you and always wanted to verify who you were? But actually, Zero Trust provides a better user experience, because the reason being is that all of this trust and verification is completely hidden from the user. In fact, so the user at the moment has multiple usernames, multiple passwords, logging into different services throughout their working day. They might be working on a health and social care partnership portal in the morning. They might move into Outlook in the afternoon, both with different usernames and passwords, having to re-verify who they are all the time. With the zero trust security model, when it's properly implemented, the user will have one single username and password for every single service that they use across the board. They'll have to log in maybe once in the morning at the absolute most. Then the device that they're using remembers who they are. That carries a credential that it can then pass on to all the other services that that user may want to use throughout the day. And the user never has to log on to another thing throughout the day. Now, of course, computers are really good at that, because they can be in the background, as I said, with the 500 million number, processing these verifications at the speed of light all throughout the day, and the user doesn't know what's happening. They just see the seamless experience of moving from one service to the other. It's also more secure. So as well as providing a better user experience, it's much more secure. And it's more secure primarily because it's much harder to make mistakes. And it is impossible to not make mistakes. We're human. Humans make mistakes all the time. With this model of moving from you can't do that to you can do this, it makes it much harder to make mistakes. So what about shadow IT? Well, actually, shadow IT disappears. Now, it doesn't physically disappear. That laptop that someone has in a cupboard that they haven't used for a year and they might get out for a different purpose later on, it still physically exists. But if you try to use that laptop in an environment which has now moved from you can't do that to you can do this, the laptop just won't work. They'll have to phone up the IT department and say, there's something wrong with this laptop I had in the cupboard for a year ago. And they'll explain, well, that's because we don't have it registered on the network. And it will be made up to the correct standards before it accesses the network. So shadow IT doesn't physically disappear, but as soon as it's added to that you can do that list, it is no longer shadow IT, and it just becomes a normal part of the network. Now, a bit of a word of warning about the term zero trust. I suspect most of the people on this call have probably heard about zero trust through third-party software vendors trying to sell you silver bullet technologies that will solve all of your security woes. And I should just point out that that's not what I mean by zero trust. Any organization that comes to you and says they've got a single product that can implement zero trust and it'll solve all your problems, give them a wide berth. The zero trust methodology is actually, at the moment, probably carried out by 3 separate technologies. I'm not going to go into a great deal of depth for each of these because that's more for a technical audience rather than a senior managerial audience, but I'll give you an idea of what each of these does. So adaptive access controls, at the moment, when you log into your network remotely, you're effectively given all access to everything you could possibly want, whether you intend to use it at that moment or not. And you can imagine a computer administrator on your IT network who might log in to check their emails. You don't really need to give them permissions to access the main server that you're running everything off of at that particular time. And what adaptive access controls means is that we can tailor what access we give to a particular user at a particular time based on the business function that they're actually carrying out at that time. And it's adaptive to the millisecond. You know, we're now moving into a different environment where we want to do a business process related to health and social care. Well, we're going to give you the permissions that you need to access the health and social care environment. We also have a technology called user to application segmentation. And what this does is, instead of the user directly communicating with the application, we define a set of ways in which we would allow the user to communicate with that application, because we can monitor users and how they work with our systems, and we know exactly what they will do on a day-to-day basis because it's the same work all the time. When a hacker comes into the environment, the first thing they do is try everything that the users wouldn't do to see if they work. By having that mediator in the middle that says, here's a list of things that you're allowed to do because that's part of your normal workflow, then we completely shut the hacker out of the environment. Workload to workload segmentation is very similar, but instead of it being a user being restricted on what they can do, it's between two services on the network. So it might be two services like Outlook and the health and social work system, where you want to email a file from one system to another. We can restrict to what we normally see, the normal patterns of behavior between those two systems. And if anything looks different from that, then it doesn't get to go on the allow list and isn't allowed to happen. So where do we start if we want to implement this zero trust architecture? Well, there are a number of prerequisites. The first one, and most important, is federated identity systems. And this is like that option that you would have at home where you want to sign up for a news website or sign up for a shopping website, and they say log on with Google or log on with Facebook. And what that's saying is, why do you want to set up a new account with a new username and a new password for this particular site when we've got a trusted intermediary that'll say, we will verify who this person is. Click this button, you can log on with Google. If you give permission to Google to send that third party your information, then Google will, whenever you come back to that site, tell that organization you are who you say you are and the service that you want should be delivered to you. Now, we can do exactly the same thing within councils' environments. Most of the councils use Microsoft products and use Microsoft identity products. And that identity product can act just like that log on with Google. So instead of having a unique username and password for every single service that you have across the board, you can have one password, you can log on once, and then for the rest of your working day, the computer will be responsible for authenticating with those services, and you don't have to worry about it. The key thing here, you're going to be giving a lot of power to that one username and password, and it would be inappropriate to implement that without something called multi-factor authentication. So as I said before with the story last week about the 40,000 compromised public sector accounts in Scotland on the dark web, those accounts could be made useless just by this one authentication process, multi-factor authentication. Now, I suspect all of you have experienced this through your bank or through your email account, or even through work. I know the majority of the councils have implemented this in some way or another across their services. It doesn't have to be that code on your phone. There's lots of different ways this can be done, but the key thing is to remove the reliance on just the username and password, so that if those are stolen, the hacker still can't get into the account. The second prerequisite is cloud infrastructure, and I'd probably put a bit of a caveat on this one. And the reason I'm suggesting cloud infrastructure is because the technology required to implement zero trust architecture and those micro perimeters requires a huge spend on hardware if you don't already have that hardware infrastructure. And you will probably find it prohibitively costly from your capital budgets if you had to go out and make your entire on-premise infrastructure suitable for zero trust architecture. So let's just examine cloud infrastructure and why it's such a good match to zero trust. So here's the model that we looked at before. Where do we start? We've got these remote users. Now we look at this again and we think, well, what are the people sitting in the regional office if not remote users? The remote users down the bottom here are sitting in their homes or sitting in a cafe or sitting in a partner's office somewhere, accessing all of the services that everyone else in the company is doing through an internet connection. Well, we don't really have a need for these regional offices for that expensive infrastructure with its own firewalls and its own servers and its own data structures. So we can just get rid of that altogether. And now the remote users are everybody who is not in the head office. But then having moved everyone who's in a brick and mortar premise, not the head office, into the cloud of remote users, Next thing we think is, well, why can't we just move all users there? Why wouldn't it be the case that all users should just need an internet connection to access all of our services? And when we get to that point, we think, well, why do we need any of the infrastructure in our head office at all? Why do we need those servers? Why do we need the server room? Why do we need to pay for the electricity costs? Why do we need to pay for the fire suppression system? Why do we need to pay for the extra security, physical security that's required for that server room on our premises, when all of our users can connect and use all of the services remotely using just an internet connection? We can strip out all of that very expensive capital equipment from our premises and replace it just simply with an internet Wi-Fi service, and replicate all of our services in the cloud, where it is much easier to do the very granular level of virtual networking. I apologize for those who are not aware of that term. Effectively, what that means is it's no longer a physical connection that defines a network, but instead the computers themselves say who is on our network and who are we allowed to talk to. And in order to achieve the very granular level of micro perimeters, we need to get that down to that level of detail, and it can only be done in software. And cloud lends itself to that, and it's already configured that it's basically a drag and drop. You can create diagrams, you can have any kind of network infrastructure you want in the cloud at a very reasonable price. So once you've got the prerequisites, where do you go from there? Well, you start small. You start a pilot. The pilot would probably look for your most critical infrastructure, the place with the most critical data, somewhere where you wouldn't want that data to go missing, that you really want to protect. It would also be a pilot where you had a large amount of mobile workforce, maybe a mobile workforce who didn't even work in their own homes, but instead worked in service users' homes. So something like your health and social care partnership might be a good place to start a pilot on something like this. It would also lend itself to joined up working between the NHS and councils, because once you get to the stage where everyone can log in and use all services just with an internet connection, then it doesn't really matter which organisation you reside in. Again, yet another reason why a health and social care partnership would make a really good pilot for this. So just as a summary then, we all have a common goal. That's the seamless integration of IT into modern business processes. The way we manage trust at the moment by saying, here's a list of things you can't do, that's called implicit trust, is very risky. There's rising costs to secure an ever-increasing perimeter. It's much better to replace those with micro security perimeters where we're able to laser focus our capital and operational spend. This methodology is called zero trust security, and we move from the can do rather than the can't do model of security. The prerequisites are federation, including multi-factor authentication, and probably cloud, unless you've already purchased some very highly specialized equipment. And we start small. Start small with a pilot, somewhere where we can target it with an area which has lots of information that we want to secure. Now remember that the only purpose of computer security is to filter the good tasks from the bad tasks. The only reason that computer security appears to be complicated is because computers can do this filtering far faster than any of us can comprehend. The most secure and cost-effective security paradigm for today's people-focused mobile workforce is zero trust. And now that you're all cybersecurity experts, you can go back to your offices and be part of the designing of the best IT architecture to support your business processes. Happy to take any questions that anybody has.
So Andy, that was very insightful and fascinating. So thank you. And I've got to say, the way that you described it, ADB, your slides, even for a technophobe like me, I found it easy to understand. So thank you for doing that. So as Andy said, we've probably got enough time for one or two questions. So I'd like you to invite you to either raise your hand or put something into the chat box if there's a particular question you have. Stephen.
Always got a question here.
Yes.
Andy, you talk about a zero trust technical environment. Do you think we've reached a point where culturally people understand that this is everybody's issue? Or do you think your solution, the technology zero trust solution, overcomes that culture that I think does persist just now?
Yeah, I think the idea that it was everybody's problem works in theory up to an extent, but attackers are getting more and more sophisticated. You need people with degrees who study this stuff every day in order to fix these problems, and relying on the fact that our frontline staff are going to protect us is only going to get us so far, and something like this zero trust environment will get us to that next level.
Okay, thank you.
Thanks, Stephen. Thanks, Andy. Andy, we've got a question from Lorne, and he mentioned he says you mentioned shadow IT. Could you provide another couple of examples of what that might include?
Yeah, the councils are absolutely full of this stuff because of the disparate organisational structures that we have. And a great example would be a head teacher within a school going out and buying 1,000 iPads and not notifying their corporate IT team, and those iPads being put onto the network, being given access to that network, and then the IT team not being aware that they exist. These are exactly the types of things we need. We mean in a more secure environment, it might be that you had some business continuity devices that you put in a cupboard and forgot about. The IT team now forget they exist, but then someone says, oh, well, we've got a new employee, we don't have a computer for them. Let's just get the laptop out the cupboard. We've now got a laptop on the network that the IT department doesn't know anything about. And that's what we mean by shadow IT.
So I think they're really good examples, Andy, because on one hand, we're all striving towards greater accessibility, especially as you mentioned earlier, over the course of the last 6 to 12 months. And sometimes our enthusiasm to do that means that we might miss some of those basics. So good and topical example. So if there are no more questions, I don't see anything come through the chat. No, I don't see any more. So with that in mind, oh, sorry, one more, Andy, and it's from Neil Fraser. The question is, does the nation have the infrastructure to cope with virtual office working of the future, and specifically power network, etc.? Thoughts on that?
Yeah, absolutely. We have more than enough power. The biggest issues with power will be things like our move to electric vehicles, and we're going to have to ramp up our production. But in terms of comparing it to Bitcoin, the thing you have to understand about mining Bitcoin is your PC and graphics card are working at 100% utility all the time, and that's why they consume so much power. Your desktop computer basically idles. It's so fast, so powerful, you're barely using 0.5% of it at any one time, so it's consuming almost no energy.
So I think that'd be an interesting example you used about electric vehicle infrastructure. So now we're about to find the real integration between information security and vehicle security, of course, with the advent of a greater number of electric cars. So that's the next challenge that we're going to face. So Andy, once again, thanks very much for the session. Really informative. I really enjoyed it. Thank you. Thanks everyone for attending.